Hey everybody, Mr. Bowman here. Another 2.7 calculus exam video. I really hope you are benefiting from them. And we're looking at the achieved questions for the 2021 exam. I want to know achieved questions, but there's actually only 2 of them in this exam. So it's quite a rough exam, a lot of merit and excellence opportunities. But the achieved easy ones were hard to get. So let's have a look. Question number 23, and these are all questions from the website numbers. So we've got a function is given by this particular expression. We've been asked to find the gradient when x is equal to 3. So straight away, I see the word gradient, which makes me think I need a gradient function, which means I've got to differentiate. So let's write down my original function. So if x is equal to 4x cubed minus 2x squared minus 7x plus 4, forgive the messy handwriting there. So as I said, I need a gradient function, so I'm going to look to differentiate that. So 4 times 3 is 12, so it's going to be 12x squared minus 2 times 2, so that's going to be 4x, and then minus 7. I'm looking at particularly when x is equal to 3, so I need to substitute 3 in. So f dash 3 will be equal to 12 times 3 squared, which is 9, minus 4 times 3 minus 7. So again, you can bang that straight into your calculator or do it step by step. So that's going to be 9 times 12 is 108, minus 12 minus 7 is going to be minus 19, which is going to get me to a gradient of 89. So it's a really, really steep and really, really positive gradient at that particular point. We're now up to question 24, which is the second and final question for this particular exam. So we've got an electric scooter traveling down a straight footpath. We've got velocity, so straight away kinematics is what I'm thinking. And here's our velocity function. And we've been asked how far, so we're looking for displacement. So displacement when t is equal to 3. So I'm going to start by jotting down my velocity equation. So the velocity in terms of time will be equal to 0.3 t squared plus 1. So to find the displacement formula, so that's st, I need to integrate my velocity. So that's going to be 0.3 t cubed divided by 3 plus t plus c. I could probably do some simplifying while I'm here, some simplifying. So 0.3 over 3 is 1/10. That's actually going to be 1 over 10 t cubed plus t plus c. So again, my issue is what is that plus c? In this case, it actually ends up being quite easy because if you think of distance, if you're at the start line and you're at the very line, no time has passed, and also because you're at the beginning, no distance has also passed. So that means the displacement is also equal to 0. So we're going to substitute that into our function. So we know all of this is going to be equal to 0 because no distance has passed. So 0 is going to be equal to 1/10 times 0 cubed plus 0 plus c, which means c is going to be equal to 0. So my actual displacement function, so the displacement in terms of time is going to be equal to 1/10 of t cubed plus t. To answer the question, we now need to substitute t equals 3. So my displacement after 3 seconds is going to be 1/10 times 3 cubed plus 3. So let's start off with this section here. So 3 cubed is 27. 1/10 of that is 2.7. That's going to be 2.7 plus the 3, which means my displacement is actually going to be 5.7 meters. And I've answered the question. So short video, only 2 questions that were achieved in that 2021 exam, but hopefully you found the video useful. Keep an eye out for the other videos. Best of luck for your exam.